everyone. Welcome back to another episode of the engineering side of data. I'm Bob Haffner. I'm joined by Arjun Narayan, and we're going to be talking about streaming today. Arjun, please introduce yourself.
Thank you so much, Bob, for having me. I'm really excited to be here. I'm Arjun Narayan. I'm the co-founder and CEO of Materialize, and excited to talk about all things streaming.
Excellent. Yeah. Thanks again. Really appreciate it. We'll jump right into the questions that I have here for you today. My first one is, what is streaming?
That's a great question. I think the best way to think about streaming is in opposition to what it's not, which is batch. So traditionally, batch has been the way people have moved data around from point A to point B, essentially chunking it all up and doing it once a day. And streaming is moving it in low latency as soon as you have the data for all these varieties of use cases you have across your company. And by low latency, I mean, sub-second, so ideally milliseconds, but certainly, sub-second, maybe tens of milliseconds. The reason streaming is its own thing is this introduces a whole new set of concerns when data is continually moving versus batch. There's certain problems that go away when you batch up data. For instance, a good example of this is a single batch of data almost always all has the same schema. So if you're thinking of relational data, thinking of data types, you oftentimes align your batch boundaries on changes to these types over time. You don't have that luxury in streaming. So streaming oftentimes brings into focus concerns that are neatly handled one way in batch, where that solution no longer is workable in a streaming context.
Okay, great. What types of use cases do you typically see with streaming?
The first thing I would say is that if it was easy enough, and this is a long, we can talk for a long while why streaming is not as easy as batch, or why so far it has not been. But in the fullness of time, we think streaming is strictly a superset of batch, because in the limit case, you can always batch up your data and still flow it through a streaming architecture. Streaming can do everything that can be done in batch. Today, that comes at a certain trade-off, and we can talk a little bit about how we can make the cost of streaming low enough that people are incentivized and perfectly happy to do more in streaming and do everything that they do in batch in streaming.
Gotcha.
So when speaking about specific use cases, sorry to interrupt you there, I want to make sure I answered the question. Today, most folks there's a high hurdle rate for streaming to clear in order to justify the expense and the operational concerns. It is usually places where time is critical. You can think of ad placements, you can think of observability, performance and network monitoring, security, real-time personalization. These are things where there are certain companies that are at the forefront. Delivery apps, for instance, tracking things in real time as they're moving around a physical world. These are places where companies have put in place the investment to give their users and customers a real-time experience. But in the fullness of time, we think, there's no inventory management that you wouldn't want to have the most up-to-date data on, even if some companies today are doing that once a day overnight.
Excellent. Yeah. So it sounds like currently streaming does have maybe a specific set of use cases, but as the industry gets better at streaming, then we'll see more, like you said, a superset of those use cases. Same as batch, right? Plus.
Yes, that's right. I think of it as you almost certainly won't. You almost certainly will move things to streaming if it was easy enough. Unless it was purely a legacy pipeline. I mean, legacy software exists in every aspect of our lives. And that's where I think batch is headed in the fullness of time, which could take more than a decade to play out.
Gotcha. That makes sense. So here's a rather broad and loaded question, but what is the state of streaming currently?
So I would say streaming is it's in the early adopter phase. it's mainstream enough that most people have heard of it, but I think it's I would put it at maybe 1% or so or thereabouts of the batch market in terms of actual data being moved around in streaming. It often has a very high operational burden when you take on a streaming project. It often requires specialized teams, and there's little to no prepackaged solutions for people to buy streaming software out of the box that works, without that manual sort of DevOps team maintaining and running your streaming architecture on a day in, day out, carrying a pager. That has to change for streaming to go mainstream. Streaming needs to become as easy to use as batch. I don't want to give people the impression that, I'm talking down batch. I really think, there's a lot of positives about batch today. You can get a lot of value for relatively little effort. You can run batch jobs using just SQL that end up running across hundreds of machines in the cloud on a regular cadence, dealing with all sorts of operational problems completely invisibly behind the scenes. And that there's a lot to be said for that. It means batch is very democratized. There's a lot of folks who can point and click on BI tools or on dashboards that under the hood cause various state-of-the-art data warehouses to operate on batches of data and give them succinct answers. None of that exists in streaming. And that, I think, is the single biggest bottleneck. Streaming needs to be as easy as batch if we're going to make any headways towards making more analytics real time.
Gotcha. So obviously you just mentioned one of the biggest challenges with streaming, right? It's more difficult than batch, right? Batch it's been around for a while. It's simple. A lot of people know it. Are there any other, I guess, challenges associated with streaming maybe that you could expand upon?
So let's sort of break down what easier means, right? So the data analytics and sort of database ecosystem it's not a new one, right? It's possibly the oldest ecosystem, or the second oldest after, say, operating systems themselves, right? So think of operating systems and databases as having built some of the most mature companies in our ecosystem. And as part of that, the ecosystem is large and consists of multiple nobody buys a single vendor data analytics solution, and that's a good thing ultimately. Most companies buy data integration tools, data warehousing tools, business intelligence tools, and perhaps multiple of each category, and they all work well together because of the standards compatibility. And when I say easier to use, it's not necessarily just from the perspective of the user. It has to play well with the ecosystem, and the vast majority of the data analytics ecosystem works well together because of all these tools speak the common lingua franca of SQL. And I think I personally would put a big stake in the ground saying that, streaming needs to be SQL, real SQL, standards compliant ANSI SQL, with all the warts that brings. I think many of us have certainly, myself included, seen a lot of, SQL we never want to see again, right? Like multi-page common table expression subquery join things that's hard to wrap our heads around. But that is the reason that all these tools work well with each other, is that they all speak the same thing and they have a standardized way in which to express complex business logic. That needs to exist in streaming, and that's what a lot of us are focused on at Materialize, certainly.
That makes sense. Yeah, the standardization across multiple pieces of the puzzle certainly helps out, I can imagine. So, yeah, one of the things I know you from is a blog post that you had up maybe a year and a half ago. It was entitled "Kafka is not a database." What was some of the motivation behind that blog post?
That's a fun blog post that we wrote. I want to sort of make it very clear that I'm a big fan of Kafka. And this is not a hit against Kafka for all things. It's a hit against the way Kafka is sometimes misused, and I think to great negative consequences. I think Kafka is a great tool, and like many tools, has the potential for being deployed in the wrong setting. And and that can cause problems. What Kafka is a phenomenal message queue. So it has really, message queuing technologies are also multiple decades old and have oftentimes been used in this sort of enterprise service bus middleware layer that everybody sort of has had lots of problems with. And Kafka was the really first message queue that really solved the message queuing problem by truly decoupling producers of data from consumers of data. Before Kafka, you never really achieved this decoupling because any services you had these dependencies because each service had to worry about what if the other services don't consume the messages that I'm sending fast enough, or what if the buffer runs out. What Kafka really presents is this API of being an infinite buffer, right? And yes, there's operational concerns. It's not truly infinite, etc. But it was the first one that was anywhere close to allowing service creators, either on the producer side or on the consumer side, to actually start to be able to think of themselves as being able to make progress in a decoupled fashion, and just make it Kafka's problem if somebody else was slow or not keeping up at speed or was not at the correct level of concurrency, etc. And that's great. The problem is that some people start using it as a database because it's a thing that can absorb near infinite amounts of storage. That doesn't mean it's a database. Databases are more than just places where you put things, right? So that's not a database. It's a file system where you can just sort of put infinite quantities of things. What commonly people rely on databases for is so much more: for data integrity, for consistency, for isolation guarantees, to be able to do transactional reads and writes and conditional writes based off of the state of the reads and things like that. And you don't get any of that with Kafka, right? So that is when you can run into problems if you start from approaching Kafka as this position of being an endless place to dump your data. You lose a lot. It's very similar to the NoSQL movement, say over a decade ago, where people were, I think, correctly upset with the SQL databases of old for being unable to scale to their read-write volumes that they wanted, and they started to strip it down and create this minimum viable database that could at least scale with the read and write volumes. That's fine, but then most people realized that they were relying on their databases to do a lot more, to be able to do transactions, multi-row transactions, complex transactions with multiple reads and multiple writes and all sorts of dependent logic. And they didn't get any of that. And the lack of that caused numerous problems for glitch, whether it be glitches on the website or far worse, right? Nobody wants to be the retailer that sells 12 of a limited run product where only 10 items have been made, and now you have two very embarrassing customers to deal with. And that's the sort of thing that starts to happen increasingly when you that's what a relational database would totally prevent. And so I wrote this post jointly with George Fraser, the CEO of Fivetran, where Fivetran is a wonderful company in the data integration space. And what we had noticed was an increasing number of painful architectures where folks had essentially thrown out the relational database and then running into problems, several years down the line, which would have totally been avoided had they had a relational database at the start of that architecture. Now, as we go on to lay out in that post, a relational database is a great place to land your data and to resolve these transactional issues. And then Kafka is a phenomenal complement downstream of that, where you can just take the events that happened and then stream those in real time at millisecond latencies to additional use cases, be it analytics, be it additional microservices in your company.
Yeah, and I must admit that when people started talking more about saying, hey, you really don't need a database, you can get all this stuff from Kafka, I did get a little caught up in that. Right. But then, your blog post was kind of a sobering reminder of what seemingly small things the database do are often very difficult to replicate. And if you go down that path of trying to solve those issues, trying to accommodate for ACID, concurrency, things like that, you're in for the long haul. I mean, people have spent decades trying to master that in the database world, and people probably foolishly thought that they could do it pretty quickly. So yeah, wouldn't be the first time, right?
Yeah, it's not the first time, right? Exactly. Every generation has to sort of learn these lessons,
Yeah.
sort of through pain and experience. And another aspect of relational databases that really helps is oftentimes what we see is people, they will mess up the data in a Kafka cluster, and there comes a point where the cleanest solution is to just purge everything and rehydrate it from your relational database, because you have some known good source of data that's actually sane in your relational database. And if you're just using Kafka, you can't ever fix that, right? So if you have Kafka, one of the benefits of Kafka is it presents itself as infinite history. Right. But the history may not always be good. You may have made mistakes yourself.
Yeah.
I mean, do you want to endlessly relive that outage that's in the history? What's nice about the relational database, you can create a better history. It's a little bit like Git rebasing your entire data.
Yeah.
It's a useful tool to have when you've made some mistakes.
Yeah. Yeah. And that's also, I think people maybe get enamored with this idea that it is a big database log, right? And I can replay things and maybe represent those in materialized view, or maybe even put those in a downstream database, but may not be all that easy. And again, if you want to relive all the bad things that happened, maybe that's a good way to do it, but not necessarily great for your sanity. So
yeah, one of the things we actually we see is it's good to have that stuff around to build your regression tests and make sure that you never make the same mistake twice. But you certainly don't want that to be the way you restart a service, is to go through every single schema change that you've gone through, the history.
Yeah, no kidding.
You actually do want to take a snapshot of known good, clean data and then continue the stream.
Yeah, no need to have a chaos monkey in the queue, so to speak, in Kafka. You mentioned SQL a couple times, right? And how you're a big believer in SQL is in terms of the language of choice in streaming. What are some of the other choices? And you can draw comparisons on, if you would, please, on SQL and some of these other language choices.
Yeah. It's funny because at Materialize we have sort of an equal contingent of SQL haters and SQL fans, and we often have a healthy discussion. It's like, well, how much better life would be with fixing some of these mistakes. At the same time, you get the primary thing we see data analytics. The primarily alternative to SQL is often some kind of Python, Pandas, Spark data frames ecosystem. That's maybe been the only sort of alternative that has gained in. There have been many alternatives proposed and failed. That's the only one that seems to have built up a certain level of critical mass to be a viable competitor to SQL. Now, we at Materialize have not done anything with that. We've gone all in on SQL to build a streaming experience that is supports all of SQL in real time. But certainly, I think that there is a world there's certainly a viable path to do something with Spark data frames and that sort of API that potentially can be as viable in the marketplace.
Makes sense. So what do you see as the future of streaming? What does it look like?
I think it starts to look a lot more like batch. I think it starts to look like, you want it, or at least what we want, or what I want, is for SQL to become as easy as batch, and for people to be able to move between batch and streaming based off of their real-time needs without needing to throw everything out and rewrite their queries, right? So I want the same SQL that runs in batch to run in streaming. Oftentimes, for instance, we see even people who want to do something specific in real time, they will begin that prototyping journey in batch, which makes sense because when you're doing data science or when you're thinking through, well, what input data is even a good predictor of the thing that I want, the outcome that I want for my business, you're going to hold a fixed data set just so you can stay sane and like poke at it and in the 14 different ways until you arrive at the query that you want to go in streaming. Today, the problem is that once they get to that point, they often have to rewrite all of that in some sort of streaming microservice and port that business logic, which is a long and painful process. And as they make additions and iterations and batch and porting that over to streaming, you essentially have this sort of Lambda architecture problem or Lambda architecture like problem where you have two different things in two different languages that need to mean the same thing, right? And it's so easy to get that wrong, to have some off by one error ruin everything because you didn't get the semantics of that porting right. We want that SQL that runs in batch to run in streaming and vice versa, because we think users should be able to move back and forth between multiple systems to achieve their business needs without needing to go back and re-architect and re-architect and re-architect. We want there to be a single unified ecosystem across batch and streaming. Another important reason for this is people will mix, and they certainly want to mix batches and streams all the time. Like your whole organization is not going to up and shift over one day. There's going to be parts of the data that are still arriving in batches, that are arriving in micro batches, some that are streams. You want to join across them. Joining multiple streams or joining multiple streams with multiple batches is a problem that is not easily solved. And until there's a true easy solution to that, which we would contend that it's just writing SQL across all of these things and having all of your batches and stream present as just relations, whether they be moving slowly or moving fast, and having that SQL work no matter which one of these things gets moved from batch to stream.
Yeah, I think that's an important note that you touched on with the consumer side, right? I mean, obviously, you've mentioned the tools need to improve, need to become more simple to use. But the users themselves need to be, they need to go through I guess a period of time of adjustment, right? Some of them may grasp it right away. And some of the use cases, like you talked about earlier with the late deliveries, right? That would be great for somebody who had a tactical role within an organization to go ahead and mitigate that risk, notify the customer, talk to the carrier to see if they can improve the situation, any things of that nature. But when it comes down to more strategic decisions and, maybe executive dashboards or things like that, it'd be interesting to see how streaming comes more into that, right? Are they looking to have that more up-to-date information, right? Are they, do they care if their number is the same as it was at 8 a.m. as it is at noon, right? Are they going to make their decisions any differently?
Yeah, the real-time dashboards are a fun one because that's oftentimes what many folks brings them to streaming. It's like, why is this data out of date? Why isn't this the latest information? And certainly in certain sectors of the industry, like say financial services and financial trading desks, that's absolutely a key value driver to just have more up-to-date information that reflects the state of the world as recently as possible. But for many, one of the things that I sort of obliquely mentioned earlier, which is folks building batch pipelines and doing data science and then wanting to operationalize that, that's oftentimes a journey we see where people adopt streaming, which is they're doing something in batch, it's working, it's the right business logic, and now they actually want to do more of it. They want to double down on it. They have the logic. They know exactly what they want. What they're frustrated with is the tooling. It is not available to take that query into streaming easily. They have to throw it all out and rewrite it. And it's this when in the situation, usually it's there's a human in the loop, right? The data science, data analysts is a human in the loop, and they're trying to up-level themselves. They're trying to take themselves out of the loop because they want it to happen in an automated fashion. It's this automation, which is when folks really see the value of real time, right? Because when you have an automated pipeline that's running once every 4 hours or once every 6 hours, and you're asking yourself, why isn't this running? Why isn't this 10 seconds? It's just it's doing the same thing over and over again. That's when oftentimes they look to streaming as the solution correctly. And that just needs to be easier. And that's really what we're trying to do at Materialize, is to enable that batch to streaming transition with no rewriting of your business logic.
That's interesting. Yeah, I've never heard it quite put so well, that connection between AI and streaming, right? They're kind of symbiotic relationship that they have between the two, and how streaming can greatly benefit AI. And productionizing it, right?
I would make it more to make it more precise. I would even say just online prediction, right? So you have, and this is oftentimes offline training, and that's fine in batch. It's online prediction when these data points are coming in fast and quickly, and you can gain a lot of, a much better customer experience by just using those most recent data points to predict whether it's customer segmentation or whether it's something else.
Excellent. Okay, great. Well, Arjun, hey, it's been great having you on. Do you have any parting thoughts?
Well, Materialize is available on the cloud, and I'd love it if you, the listener, would check it out. Thanks so much, Bob, for having me on the show. I really enjoy talking about all things streaming and SQL, so thanks for giving me the opportunity.
Yeah, excellent. I really appreciate you coming on. And folks, you'll see that we've got some links to Materialize and some other things that we've got with from Arjun in the show notes and in the video description. And please subscribe if you haven't already, and like the videos and share them if you would, please. And thanks for listening, and we'll see you next time.